So let's discuss today's POTD Leetcode 396 rotate function, where we will be given an array nums of length n. We are given an operation f of k whose definition is given, and I will discuss it during the problem walkthrough. Our main objective is to return the maximum value among f of 0, f of 1, f of 2 till f of n minus 1. And the test cases are generated such that the answer fits in a 32-bit integer, so no case of integer overflow. Two examples are being given, and looking at the constraint we can see that n, which is the length of the nums array, is 1e5 or 1 lakh. So we can think our solution in terms of n log n complexity or n complexity, but we cannot think anything in order n square. We have to complete this class in order to complete the problem. So let's move to the example walkthrough. I will take this example one. So example 1 has this array 4, 3, 2, 6. The indexes are 0, 1, 2, 3. F of 0 means that you will multiply 0th index with 0, first index value with 1, second index value with 2, and third index value with 3. So basically 4 into 0 plus 3 into 1 plus 2 into 2 plus 6 into 3. That is our f of 0, whose value is 25. Then if you rotate it once clockwise, this 6 will come to the 0th index and they will right shift once. So 6, 4, 3, 2 is our new array. So we have f of 1, and this is called f of 1. So now if I multiply 6 with 0, 4 with 1, 4 with 1, 3 with 2, then 2 with 3, and then add them, I get 16. This is the value of f of 1. Then I rotate it again once clockwise, so this 2 will reach the first position and others will right shift once. So this is called f of 2 because we have rotated 2 times from the original array. And the value of f of 2 will be calculated by multiplying this 2 with 0, then adding 6 into 1, then adding 4 into 2, then adding 3 into 3, which is 23. Similarly, we rotate it again and we get this array, and this value is f of 3, and the answer is 26. And if we again rotate it, we get the original array, so we have to stop till f of n minus 1 only. Now out of these f of 1, f of 2, f of 3, f of 4, we need to find the maximum value, that is the 26. And similarly, in the next example also, we only have one element in the array, so only f of 0 is possible, which is 0 into 100, and that is 0. Now the question is that if we try to simulate this, we can first see what is the array, we can calculate the function, we get the value, then we rotate it once in clockwise direction, and then we find the value of f, and then we see if it is maximum or not, and do it till n times. So overall, in order to do it n times, there is one n, and each time we have to do some inside the loop, we have to run across in all the indexes, so n square will be the time complexity. So brute force cannot pass, so we have to think something optimal. Now here we said that we will try to simulate the entire procedure. We will take the array, we will rotate it, but instead of rotating the array, we can also observe that if we write the array in this way and then we write the indexes of the uh, we just write the indexes, like for f of 0, when if the array is 4, 3 to 6, so the indexes are 0, 1, 2, 3. Then in order to find f1, we rotated it once and then we got this array. Now if we write the index with respect to the original array, Then this 6 is at 0th index, so we wrote 0 here. This 4 is at 1 index, so we write 1 here. Then this 3 was initially at 1, but now it is at 2, so we wrote 2 here. And similarly, this 2 is now at 3, initially it was at 2, so for 2 we wrote 3 here. Similarly, if we rotate it again once, these 6 2 will come at the front, so 0 1, and they will be shifted once to the right, so 2 3. And similarly for f of 3, this was f of 0, now this one was f of 1, f of 2, and for f of 3 we have this. Now if we try to see that, let's say that I calculated what is f of 0 in linear time by doing the exact operation, that is 0 into 4 plus 1 into 3 plus 2 into 2 plus 3 into 6. Now for f of 1 I rotated the array, and I didn't rotated it like I didn't simulated it. Let's assume that in our imagination we rotated it. So the indexes will be 1 2 3 zeros. 6 will be at the first and they will be shifted right once. So these are the new indexes. So here f of 0 was 25. So we wrote that, and we can see that till f of 0, 4 was present 0 times, 3 was present 1 times, 2 was present 2 times. So this 25 has 0 times 4, 1 times 3, 2 times 2. So, and now in f of 1, the value of 4, 3, 2 index are 1, 2, 3. So now 4 will be once in f of 1, 3 will be twice, and 2 will be thrice. But they are already 0 times, 1 times, and 2 times. So it means that we have to add them one more time in f of 0 to get f of 1. So I will add, if this is f of 0, I will add 4 ones, 3 ones, 2 ones. And I won't do this by using a for loop. I will use prefix sums or some other way. We will look into that later on. Let's assume that we do it using prefix sum. So we are, for f of 1, 0 will be at the last index. So before that, all these values will be added once, because initially it was 0 1 2, now it is 1 2 3. So the difference is once, meaning one more time they will be added. So we can just add their prefix sum. And now 6 has 0 index. It means that initially it was 3. So I have to do minus 3 times 6. So in f of 0, I did minus 3 times 6. So now, and I added this, so I got f of 1. Now I move to find f of 2. In f of 2, I will first add f of 1. Then we can see that 0 will be at this 0 1 2 index. 0 1 2, in this index 0 will be present. So before that, the values are 2 and 3. The index values are 2 and 3. And for f of 1, they were 1, 2. So we have to add them once. So we will add 4 ones and 3 ones using prefix sum. So it will be 7. So 16 plus 7. Then here the third index, this second index 0 1 2, this 2 index is 0. So it means that initially it was 3, now it is 0. So I have to subtract 3 times 2 from this value. And then now after this, as in f of 1, we removed the contribution of 6 by subtracting 3 into 6. So here in f of 1 we don't have any contribution of 6, but here we need it once. So I will add 1 times 6. So 23 will be my f of 2. Then I will try to find f of 2. In order to find f of 3, sorry. Now in order to find f of 3, I will add the value of f of 2. I know that my 0 will be at 0, 1, 1 index. So before that, what we have? We have 4, whose value is 3. How much was his contribution in f of 2? It was 2 times. Now 4 is present 3 times in f of 3. So it means one more time I have to add. So 23 plus 1 into 4. Then I subtract 3 times 3. Why? Because in f of 1, 3 was present 3 times and now it is 0 times. So minus 3 into 3. And after that, initially in f of 2, 2 was present 0 times, 6 was present 1 times. Now 2 is present 1 times and 6 is present 2 times. So it means the difference is 1. So we have to add them once. So I will add 6 and 2 and I get 26. So this, and while doing this I can keep track of the maximum value. So 26 is the maximum value, so that will be the answer. Now why is this linear time? So first of all, finding f of 0 is linear time. It will take n. Only one for loop is required because 4 into 0 plus 3 into 1 plus 2 into 2 plus 6 into 3. So f of 0 is it can be easily calculated in linear time. Then I will take f of 0 and I know that the this 0 acts as a partition. So I know the last one in f of 1, the last index will be the 0 value. So before that, everyone will be added once. So in big of 1, we can get their sum by using prefix sum. And then whatever value is after this will be added once. But as here there is no value after this, so nothing is added. But if we move to the next one, that is f of 2, we can see that the 0th index is our partition value. Before this, these value will be added once using prefix sum, and these value will be added once using prefix sum, and we will remove the contribution of this partition. Similarly, in f of 3 also, the partition's contribution will be removed, their contribution will be added with the previous one. So in this way, and these individual operations are big of 1 operations. So overall, it's just an linear operation. So it will be big of n. Now, if we use prefix sum, we will also need an array. So space complexity will be big of n. So till now we saw that we can solve it in linear time, but space complexity was big of n because we were using the prefix sum technique, so we have to keep an extra array. Now we don't need to do that because let's say I have two variables where sum is my total sum. This is an variable. This is a variable which keeps the sum and an end variable. Now f of 0 can be calculated in a single loop. Then I write another loop outside of it and I start looping from the last index and end is initialized as the last index value 6. So sum is 15, 15 because 4 plus 3 plus 2 plus 6 and end is 6. Now in order to find f of 1, we take f of 0 which we just calculated. We do n minus 1 times the current index value which is the v of n minus 1, yani 6, 3 times 6. Then we add 15 minus 6 which is sum minus end, because if we remove end from the total sum we get these values which we discussed that we have to add it once, and then this is our f of 1. So next we move to the n minus 2 index, and now we will take f of 1 which we just calculated, which is 16. We will subtract 3 times 2 because we have to subtract it 3 times, and that is n minus 1 times 2. 2 is this v of n minus 2, and then we have to add, and before doing this I will update my end by adding the value of the current index, that is this. So 6 plus 2 is 8. So I will do sum minus end. So I get the answer from this side, and now I have to also add values from this side as we discussed above. So I have to add 6 here. Now I already added 2 to end, so I have to remove it again. So that is why I did end minus v of I, where I is n minus 2 index. Then I move to the n minus 3 index. Basically I'm running a reverse loop. Now my sum is 15, my end will become 8 plus 3. Why plus 3? Because at this index 3 is initially there. So I do f of 2, which is 23. I do minus 3 times 3. Why? Because n minus 1 times who is sitting here? 3 is sitting here. Then I have to add sum minus end to get the contribution from this side, and I have to add end minus v of I to get the contribution from this side, and then finally I will break out of the loop, because there is no point of going back to this first element, because it will essentially mean I reached back to f of 0, and every time I do this I keep track of the f of k values and take the maximum and return it in the end. It will become more clear when I move to the code. Let's move to the code. Let's start the coding part. I renamed the array as v and took its size. Then we discussed that we will take the sum variable and end variable. Sum is basically the sum of the elements in the array. Then end is 0. Then answer is something value which is very negative, because we need to give the maximum value, and our array can have negative values as well, so answer could be very negative, so we have to take the most possible negative as the default one, and we'll return answer. Prev f, so we first find the value of f of 0 and store it in prev f. Then we go to we start looping from n minus 1 index, and we only need to go till index 1, because index 0 represents f of 0. We don't need to do that again. First thing was we will take end and add v of I to it. Then the current f is prev f minus n minus 1 times v of I plus sum minus end and plus end minus v of I. Then prev f becomes cur f, and answer is max of answer comma prev f, and also need to do it here so that prev the f of 0 is also registered. So the time complexity is big of n, because this is a linear loop, this one is also a linear loop, and this one is also a linear loop of size n, and space complexity is big of 1, because we only used this sum variable and n variable If we use prefix sum, then we would have needed another array. That's not required in this problem. So that's it. Thank you.